All right, happy Monday, everybody. I hope you had an awesome weekend. So on Friday, you went around the room and found 6 problems. Here are the answers to the first 4. So I will let you take a look at these. So remember, for number 1, you're using your midpoint formula. For number 2, you're using the slope formula. Number 3, you had to start with the slope formula and then use your your point slope form to transform it into your slope intercept form. Number 4, you had to use distance formula. If this went too fast for you to check, these answers will be posted on Moodle. Here are the questions 5 and 6. Now, number 5, you needed to use slope formula to get your slope, then use point slope form. Then you had to have your final answer in general form, which means you had to clear the fraction. So my advice would be to distribute first. So in this step right here, distribute first and then clear the fraction. So right here where I have the parentheses and then I'm multiplying everything by 3, that's my clearing the fraction step. So my advice is always distribute first, then clear the fraction. It'll avoid any silly mistakes. Number 6 might have been a little confusing, but it's actually very simple. So if you have to find the slope and equation of a vertical line and they only give you 1 point, a vertical line has an undefined slope. Because it has an undefined slope and it's vertical, we know it's going through the x-axis. So it's just a matter of figuring out where on the x-axis is this line going through. We always know that our points, our ordered pairs, the x value is first and the y value is second. So when they give you a point, they're giving you the x and the y value. So that means our line, if it's going through this point, it has to be going through the x-axis at -4/3. If this was asking you for a horizontal line, then you would have used the y value. So if it asked for a horizontal line, you would have said y equals 1/5, and the slope would have been 0. Great. Okay, now you had a review problem. So we have to find the equation of this line, and the answer is going to be in slope-intercept form. So the first step is to always find the slope. So we have 8 minus 29 over 20 minus -15. So this is going to be -21 over 35, which reduces to -3/5. So there's your slope. Then we need to use point slope form. I'll choose the first point. Y minus 29 equals our slope times x minus x1. That becomes a plus. Now we distribute. Y minus 29 equals -3/5 x minus 9. Add 29 to both sides. Y equals -3/5 x plus 20. So there is your answer in slope-intercept form. Okay, new set of notes today. We're going to look at perpendicular lines today. So perpendicular lines, they can be lines, but they can also be raised segments, and they're going to intersect in a special way because they're going to form right angles. So let's draw 2 intersecting segments. I'm going to put some points here. Say A, B, C, and D. Now, we know that if we see right angles, we use the little box, the little square inside of the angle. So when you look at this picture, you know that we are forming right angles here. The symbol that we use for perpendicular, it looks like an upside down capital T. It also looks like two segments that are perpendicular. So the notation would be segment AC is perpendicular to segment BD. As soon as you know that you have perpendicular lines, I want you to mark the right angles in the picture. Okay, so as soon as you know that you have perpendicular lines, make sure you mark those right angles. Okay, a couple rules that we have. If two lines are perpendicular, then the pair of adjacent angles they form would be congruent. They would also be a linear pair. The second rule, if two lines are perpendicular, then all four angles they form are right angles. You can see that in the picture that we drew already. And rule number 3, if two lines are perpendicular, then all four angles are congruent. Great. Okay, here's another rule. The distance from a point to a line. So here's a point, here's a line. In order to have the most accurate distance, when we measure the distance between this point and the line, we want to use a perpendicular line segment. We want it to go straight to that line, and in order to do that, it should be perpendicular. So we're going to use that perpendicular line segment. All right, the last term, and this is a big one, perpendicular bisector. We just learned what perpendicular means. We already know what a bisector does to a segment. So a perpendicular bisector, it could be a plane, a line, a ray, or a segment if it's perpendicular and a segment bisector, which probably seems obvious. So let's get this all figured out. Let's draw segment AB. We're going to put point E on that segment, and then I'm going to draw a line through E. This is going to be line CD. So the problem would tell you that line CD is the perpendicular bisector. Notice I used our new symbol. Of, oh, where's my O there? There we go. Of AB. When we see this, we know a couple of things. The perpendicular part tells us that line CD is in fact perpendicular to segment AB. So as soon as you know this, what should we be doing? We should mark the right angles. So I'm going to do that right now in the picture. Mark the right angles. Now, the segment bisector. We have two thoughts whenever there's a segment bisector. Your first thought is that there is a midpoint. Now, line CD is the one doing the bisecting to segment AB. So AB is getting the midpoint. So E is the midpoint of segment AB. And when we know there's a midpoint, what do? We use those tick marks. So we know AE is congruent to EB. I'll put those tick marks right in the picture there. All right, awesome. So that's everything we know about a perpendicular bisector. Now, if I were with you guys today, we would have had the computers and played around with them a little bit. But I just want to show you something cool with this GSP software and the perpendicular bisector. So I am going to make a segment, and I'm going to label it. I'm going to double click because I want to change the letters. I'm feeling funky today. K-E. All right. Now I'm going up to the arrow tool, and I'm going to click in the white so that nothing's highlighted right now because I just want to click on my segment. I'm going to go construct midpoint. I'm going to label it M for midpoint. Now I'm going to construct the perpendicular bisector. So I need to make sure that this is highlighted so that the computer knows that I need it to go through the midpoint. And I also need to highlight the segment so that the computer knows this is the segment that it has to go through. So I'm going to say construct perpendicular line. Now we know that this is a perpendicular bisector because it's going through the midpoint. I made M my midpoint. So let's measure some stuff. So from K to M, I'm going to measure the distance. And from M to E, we can see that they're exactly the same, and they should be. And watch what happens. If I move this around, notice how, no matter how I move it, those distances are staying the same. That's how we know it's a true midpoint. And you can also see that my angle appears to be staying a right angle. So let's put another point up here. I'm going to call it point L. Now, I want to, sorry guys, it paused. So I'm going to measure one of these angles here, and the computer needs to know exactly which angle I'm talking about. So I have to name my angle with 3 points, just like we do when we're talking about them. So angle KML, I had to click those points in that order. Now I go up to measure angle, and look, it's a 90-degree angle. And no matter how I move it, notice that 90 degrees is not changing. So that's how we know it's a true 90-degree angle. Cool. All right, let me get that out of the way a little bit. I'm going to draw some segments connecting these points together. And I'm going to measure these. Let's see, measure length, and look at that. Now they are the same. So even if I move this point up and down on the perpendicular line, those segments that I just created don't change. So that's something that I want us to see for when I come back tomorrow. We're going to talk about this situation where if we have a perpendicular bisector and then we connect to make these segments here, look, even if I bring the point way down here, those segments didn't change. So this is going to be a rule that we talk about tomorrow when I'm back. So for the rest of today, Mrs. Penny is going to give you a sheet that has some problems on it. You actually already completed problems 1 to 6 on Friday. Those were the ones that were posted around the room. I would like you to work on 7 through 12 for the rest of the period, and I'll be checking everything that was assigned tomorrow. All right, I hope you guys have an awesome day, and I'm excited to see you tomorrow.